squish to it. Okay, ready? 10.3. What are we doing? What are we doing tomorrow or today? Hyperbolas. Ooh. Ellipses. Okay. Lines only had x to the first, y to the first, and numbers. True? Okay. Parabolas had one squared guy, maybe with like a single, but the other guy had to be just to the first power. Because parabolas only... What do ellipses have? So therefore, I'm going to have an ax squared and a by squared, and maybe some cx's and dy's, and maybe, oops, I don't know. The proper form would technically, yeah, move it all to one side and have it be 0. I was allowing for the fact that you could have things on both sides, but Matthew said 0 because technically if he's a number, we'd probably move it all. You know, that's okay. Not a big deal. Bless you. But since ellipses both are squared, there's not even like different variations like parabolas. Parabolas is like the x was squared or the y was squared, but not both. But ellipses, they're both always squared. But once again, where's your center? Where are your vertices? Where are your foci? Where's your ellipse? Unless we put them into the clue form, like we did with lines ever since Algebra 1, like we did with parabolas, maybe in different ways before now, but now we're doing with the 4p form, and like we need to do for ellipses. For ellipses, do you guys notice that either form always looks like this, at least? And maybe last night you realized all that really changes is the bottom number squared. It's always going to have a number squared, and if it's an ellipse, a true ellipse, they'll be different. If it's a circle, they'll be the same. Now, I get that there are these A's and these B's, and sometimes the A could be here, and sometimes the B could be there, or we switch them. But it's just numbers. And A is the name that we give the dude who's bigger. Could the bigger one be under him? Sure. Could the bigger one be under him? Sure. But is it the same form? It's the same form. I have a number squared, one of them's bigger. Okay, cool. So do you really even need to memorize two forms? Not really. Just realize one of them's going to be bigger, and the bigger one is the major one. So sometimes the major one's under the x, which means it's going to be one of those horizontally dudes. What do I mean wins? Well, if his denominator's bigger, okay, cool. He wins, he has the major, it goes that way. But what if the y minus k guy wins? What if this guy's denominator's bigger? It's squished the other way. Yeah, it's squished vertically. And with ellipses, remember how we have our major axis where the vertices are the edges and the foci are somewhere in between? Not just any somewhere, but technically a C distance. Wait, where's C? I don't see a C. Do you see a C? There's a special formula for C. That looks like an E. I apologize. That's not Euler's number. Not E. And if the other guy wins, well, I just had the major axis. Not going like that. Anyway, the major axis-ish with a vertex there, and a vertex there, and a focus there, and a focus there. Where the focus is C away. And remember, the vertex is going to be A away. So A goes to the vertex, C goes to the foci, either direction. A goes to the vertex, C goes to the foci. A goes to the vertex, C goes to the foci. How do we get from here to here? Very similar to how we got from here to here. We complete the square, but instead of having to only complete the square once, getting the y's and the x's on the other side, how many times do we have to complete the square here? Okay. Do we have a summary though? Oh, there was one more dude they asked for that had a formula. Who's the one other dude? Yeah, eccentricity. And we won't even go into the English of, I don't know. Most of the BC kids knew that eccentric meant like out there, kind of weird, kind of strange, kind of apart from the norm, kind of unusual. But there was one, to make you guys feel better, there was one that was like, oh yeah, wealthy. I'm like, They're like, oh yeah, because of, and when I brought up Iron Man, he's like, oh yeah, because he's an eccentric playboy. And I was like, okay, well, you're not the only one, Jason. Anyway, so coming back. We need to grade 10.3, but we've done a huge summary of 10.1, 10.2, 10.3, because is there a lot to keep track of? Yeah. But are there, now there are some weird things, like these formulas are kind of just, memorize them. Sorry, memorize them. But are there some similarities to what we're doing? Like we have to get to know these shapes, and we have to get to know whatever form they give it, put it in a form that makes more sense in my brain, and then know how to use the nice forms to get the clues that we need. Does that kind of make sense? There's similarities. So that's great, and let's not get hopefully too discouraged, because we can pretty quickly summarize or contain what you need to know in these sections fairly simply. And to be honest, I think it's actually simpler to say you need to know this for these sections than even some of those nasty trig sections where it was like T-proofs. I don't know all the formulas and get really good at what you're doing. That's hard. This one, it's like, no, just know the shapes, know their pieces, know how to get it into the forms where you can see all the pieces, and then just tie it all together. I know it's hard, but I can summarize it a lot easier than other chapters. So hopefully that kind of helps those of you that are like, oh man, there's a lot to study, and hopefully you have the desire and the willpower to start studying. Start making formulas. Start trying to force your brain to learn and to be able to use all of these clues for these shapes. So ellipses. Ellipses, the grand finale. Number 6, not the grand finale, sorry, up to where we are right now. It's the climax of our review. 6 matches with C, because if you guys noticed, x minus h, y minus k, the center was 0, 0. Only 2 graphs had that center. And who won? The x guy or the y guy? X guy. So how is it squished? In the x direction. Horizontally. The other dude, I think, was squished vertically because the y won. So he has the C, and then this guy, the center was at x minus h, negative 2, and y minus k, negative 2. The center was at negative 2, 2 is one of those removed ones. And who won? So it was squished in the horizontal direction. Hopefully you guys see that, because you're supposed to be not just showing me A, B, C's, like the matching, but also the pictures should be on there to help you review this as well. Number 14, I think they gave you clues. If you guys didn't read the directions, which I have you right, you would have missed, yeah, center at origin. You would have been like, what the heck is the center? But they said origin. I know, struggle, right? Read those directions. You should have written them. Anyway, center at origin, 0, 0. You knew the HK, which is why you just have x squared, y squared. The foci, how far away are the foci from the center? Which is why C is 2. They told you, now this one was tricky, they told you the length of the major axis, which the length of the major axis is the entire distance, like the diameter. So when they told you the whole length is 10, what would your A be if it's only half? Oh, yes, which is 5, right? 10 divided by 2, which is 5. So they say the major radius, is 5. And from that, they were able to take their well, they rearranged it, but if you guys did your C squared equals A squared minus B squared, plugged in C, plugged in A, solved for B, squared is 21. What would B have been? Which is nasty. But if you take square root of 21, and if you square it, it ends up just being the 21. So you put in the 25 for underneath the x because it was squished in the horizontal direction. And then you put the other guy in the other denominator, and dun, 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 dun. But why was number 26 a little bit harder? Yeah, you guys are saying a few things. The center wasn't at the origin anymore. So now we had to go ahead and do x minus h, y minus k, which is why hopefully you got to here. They told me the vertex. Well, that's a weird clue. Did anybody draw a picture? Please tell me yes. If you understand what a vertex is, I understand it might not have been too bad to not have to draw a picture, but just in case, 2, -1, there's my center. A vertex is at 2, I should show that, 1/2. What's a vertex again? The top and bottom, the outer edges of the major axis, right? So we can figure out the distance, the distance from the center to the vertex A. True? Figuring it out, but maybe some of you thought about it. Not, ooh. Oh, I put my point in the wrong place. Is that what you guys tried to let me know? Sorry about that. It's 2, -1. So that's a distance of 1.5. So what's my A? So technically I could go 1.5. If you want to show your shape, you can go 1.5 in the other direction also. But to make an equation, okay, I need my H, I need my K, which we get from there. I need my A, which we would get from the distance clue. Oh, that's 1.5 away, which is why they plugged in 1.5 or 3/2 there. But how'd they get? There was another clue, and the other clue was the minor axis length is 2, which means the whole length, which means 1 in each direction. Does that kind of make sense? You have to go 1 in each direction. So B was equal to 1 to make the whole thing, the axis, be 2. And so then you plug in 1 for B. The only other thing is that they said that 3/2 squared is 9/4, and they said dividing by 9/4 is multiplying by 4/9, which we saw yesterday. I think we might have another even or two. Let's start with 38. He's the easier one. Can you guys check your clues? You were given the x minus h, y minus k over b squared because he's smaller, a squared because he's bigger. But it's kind of hard to tell. This is pretty circular because 12 and 16 are fairly close to each other. Yeah, smaller eccentricity, closer to a circle. Good job. Good connection. But maybe some of you can tell this is a little bit squished, right? It's a little bit taller than it is because square root of 16/4 is bigger than square root of 12, which is 3 point something, something, something. Hopefully you guys can see how they stole out the HK, how they square rooted to get the A, square rooted to get the B. Square root of 12 is square root of 4 times 3, which is 2 root 3. Plugged both of those guys into their formula to find C because they needed C to get to their foci. And once again, ever since, especially section 2, I've been telling you guys, I think pictures help. Because if you did your -3, 2, and if you got your 4 up and 4 down from this guy, if you got your, okay, 2 rad 3 is kind of awkward. Because it'd have to be 3 point, a little something more. One direction and the other direction. Maybe it would have helped for the foci, because the same way we go along the major axis to get to the vertices, we also go for our foci. So we're going to go up to a focus, and we're going to go down to a focus. But wait, we need to know how far up, how far down. So once you find your C to be 2, you're like, oh, I'm going up 2. Oh, hey, what point is that? Well, that's -3, and now I'm at 4. Okay, cool, -3, 4. I have to go down 2. Oh, hey, now I'm at -3, 0. Maybe you don't have to memorize the formulas. Maybe the graph will be enough if you just know where the major axis is, and you know your distance and say, hey, go up, go down. Got 'em. Dum, dum. Vertices, go up, go down 4. That's -3, 6. That's -3, go down 4. -2. Maybe the graph would have helped. And what's that? Centricity again? C over A. Good. And what's 2 over 4? But wait a minute. C isn't just 1 away. C is 2 away. And A isn't 2 away. A is 4 away. Eccentricity. When you take a fraction, what was your C and what was your A can be reduced to look different, right? My C is 2, my A is 4, my eccentricity just reduced. Why am I telling you that? Well, I think there was a question in homework that made you deal with that a little bit. I think it was an odd. But before we get there, number 48. Why was he one step harder than all the rest? He was the nasty form, right? And what do we have to do with the nasty form before we can really deal with them? And how do we transform? Well, here, I can just show you this one, can't I? What do we have to do? Group the x's, group the y's, move the numbers, fill, 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 simplify. We did this though, yeah? So let's see how we did. Did they group their x terms together? Did they pull out a 9 to get the x squared minus 4x and fill in? Whew, they did a lot of math in one line. But fill in the blank by cutting in half and squaring? Did they group the y squared terms and see there was a shared 25 they could pull out, and then they took half and squared to fill the blank? But why is there a 36 and a 25? I see a 4 and a 1. 36, look to the outside, good. Look to the outside, 25. And when you simplify that, you get, whoa, you get 1? But I thought I was supposed to divide. It's weird. But when you multiply by a fraction, I need denominators to get my A's and get my B's. And dividing by 1 isn't going to get me anything. By a fraction, I know it's weird, but it's the exact same thing as we just never go this direction. Multiplying by a fraction is the same as dividing by its reciprocal. This is a tiny, tiny, tiny ellipse. Do you see him? It's like a little... Multiplying by a fraction is the same as dividing by its reciprocal. So how do I get A and how do I get B? Square root. What's the square root of 1/9? What's the square root of 1/25? 1/5. And so who's my A? Well, my A is actually this guy. But 1/3 is a whole lot, well, it's more than 1/5. So who actually wins? X. So why is it, oh, that makes sense. He's squished in the, because it's going to be a little, I can't even show it, a little burp of 1/3 and a little burp of 1/5. From where? From the center, of course. The center is what you guys get after you finish completing the square of 2, 1. So if you notice, 2, 1 is my center. I go over a third, back a third, and that's how we ended up getting these nasty vertices of 2, which is 6/3 plus a third, or 6/3 minus a third. There we go. Foci, you'd have to go plug into your little baby formula, which they didn't show the work, which is kind of sad. But you would have gone ahead and done your c squared equals a squared minus b squared, which I know is gross. We'd have to get common denominators. Oh well, 9 times 25, 9/4. Isn't that $2.25? So we have a common denominator of 225. 25 minus 9 is 16. Oh my goodness, 16 is a perfect square, and so is 225. So it's nasty, but it's possible. So 4/15 was my C, and don't you always go C away from the center to get to the foci? So 2 would be 30/16. What's 30/16 plus 30/15, my bad. 30/15 plus 4/15? Oh yeah. 30/15 minus 4/15? Oh yeah. Got him, coach. Just had to be not afraid of fractions. And this whole step of multiplying by 9 and 25 means dividing by the reciprocal. That was hard. That was hard. Just a little baby ellipse. Okay. Oh, did I not give you guys a weird one with like 6 and 4 and 3 and 2 and something, something, something? Maybe I didn't. Do you guys have any questions on the odds? I totally thought there was a weird odd one. 53? Let's go peek. Anything else on the odds, guys? Going once. Twice. All right, we'll peek at 53 real fast. Get your notes out and ready. Section 10.4 will be there quicker than you know. 10.3. Nuclear cooling towers. That's next section. 53. Yeah, actually, that's similar. Oh, I gave you guys the easier one. I must have given honors the harder one. Okay. 54 is just a little bit harder than 53. But yeah, Lauren, those were actually exactly the type I was looking for. Thank you. 53. We can peek at 54 real fast as to why it's harder, but not for long. Yeah, this one was actually kind of nice. Vertices. Do you guys see how this? How many of you can just look at the points and know the center is 0, 0? Okay. The rest of you, if you can't look at these and know the center is 0, 0, it's no shame. No shame in graphing. Now, these are the edges of the, you now tell the center is 0, 0, right? Take that distance, cut it in half, the midpoint. So some of you mathematically can think of, oh, negative 5 to 5, 0 must have been the middle, but some of you might need the graph. But eccentricity, remember how he's C over A? Is A 5? Oh, yeah. Okay, so C had to be 3. 2, 3. I could graph that 1, 2, 3. But what am I actually supposed to be doing? Oh, find the equation. So because the center is 0, 0, do x squared y minus 0, just x squared y squared. My A I know, and he's along or out horizontally, which is why a squared or 25 is going to go there. 5 squared. But who am I missing? But don't we have that little formula we can just plug and chug into? So I have 25 minus I don't know you is equal to 9. My A's and B's and C's should have, sorry, I don't know where on earth or how on earth I got an A just randomly. You should have negatives on both sides that cancel out if you ever do get a negative. B is equal to 4, so can I just make it a 16? Well, you can't square root a negative any better, so you'd have to move it to the other side. Oh, well, it's up to you. I guess you could just assume you made a mistake and change it, but Joe, there are these conics called degenerate conics. So if you ever got like this and a negative number, it's a degenerate. It looks like an ellipse, but if this is a negative number, it's not an ellipse. So you would have to go back to the beginning, move it all to one side, and try to get y by itself and figure out what it is. It'd usually be 2 intersecting lines. Yeah. That has been made to look like by squaring both sides is usually what it is. But this one is pretty easy because do you guys see how A was the 5 and so then C was the 3 and then just solve? Can I just show you the harder one that I didn't want to stress you guys out over last night so I didn't give you? Can you look at number 54? He's not just harder because he's even and you can't cheat as well. I mean, get help as well. But this is from me asking my AP Calculus AB kids what percentage of kids on campus they thought have cheated before. I was like 90, 95, 99. No, 99.99 except for James Calvin. And I have personal testimony from James Calvin, even he has cheated before. So, doesn't mean he currently does. But he's a humble guy, he wouldn't lie, right? Coming back. Well, I said to the class, I was like, I've cheated before. I've cheated people on their time and on their resources and on their... I've cheated on tasks and like done it in a crappy way. Maybe a different cheating. No, I did cheat when I was in elementary school on a spelling test. That was back in Ohio, so I would have been less than 5th grade. But that's not to say that I'm all well and great. That's just to say that I think the integrity of our school system and our students in our school system is sadly. Cheating is much more convenient than it used to be and much more accessible. And I think to some extent you guys are much more overloaded. It used to be when you left school, you left the drama unless someone called you on the phone. It's not your life anymore, is it? You have drama 24/7 if you let yourself, if you don't put the phone away. I know there's always been drama inside, but anyway, all that to say, I'm sympathetic to your plight, but that's not to say that I'm not concerned about even people that are like, I'm taking a stand for what's right. compromising in so many ways and not realizing it's dangerous. But anyway, all I have to say. Life lesson, however you want to take it. But I am sympathetic to your plight. Please don't hear that that was like judgment, condemnation. It's more of just a watch out from someone that's a little bit older and cares. Cool? But coming back. If the vertices are plus or minus 8, I know I shut it off, but you guys see the center's at 0 again, right? Okay. If the center's at 0, 0, and if you don't worry, no stress. Oh, yeah, it's the other direction, right? Okay, so now we know. Still 0, 0, but isn't this guy winning now? We're still missing this guy. This is C over A. A's not 2. Joe's thinking through ways to do it. Didn't we just see an eccentricity that was 2 over 4 and became 1 over 2? The 1 and 2 wasn't the C and the A, it was a reduced C and A. Good. The light bulb came on. For the rest of you guys, A is not 2, so is C 1. So where did 1/2 need to come from if A is 8? You see it? It would have been a little bit messy, which is why I didn't give it to you. A isn't 2, so C isn't 1. A is 8, so C had to be 4. That would have been a bit messy. I mean, 4 over 8 is 1/2. It's just hard to see. So then your C would have been here, your C would have been here. How do you find your B? The only way it would have worked to find your B correctly is if you had found the correct C, had the correct A, and solved. So anyway, a little bit out there. But eccentricity, you can't always take it. This is what I wanted to show you. Eccentricity, you can't always take it and say, you're the C, you're the A, done. Ha! Because it could have been reduced. Does that make sense? Okay. More of just a warning. And I don't think, I mean, if I didn't give it to you in homework, I doubt it's on a test. But I just wanted to show you it to you because it is one of those watch out warning things. Okay, here we go. Section 10.4. Thanks, Lauren, for that question. That helps me with what I was trying to show. Hyperbolas. Guys, I know it's a little overwhelming, but come on. A new shape, you knew there were new yellow boxes. Does that make sense? Nice thing is, this is the last new conic section. There is one more section after this that we're doing before our test. It's the 75 pointer one. Because chapter 10A, 10B, there's a little, like probability was to the last chapter, we have a little extra burp after we finish 10A. Right now, I have the test as Monday, because we're going to take all day today on hyperbolas, meaning 10 minutes. And all day, you're welcome, tomorrow, literally all day tomorrow on hyperbolas. Dealing with the yellow boxes, dealing with the shape and its pieces. Dealing with the shape and its pieces. But if you guys notice, as soon as you write that center vertices foci, I think this is similar to 10.3 in lots of ways. Even look at the equation. How close is that equation to ellipses? So close, except for one little thing. The minus instead of the plus in between. So maybe if we can just get the shape down, get its pieces down. If we can just get the shape down and its pieces down. So instead of a squared minus b squared, it's going to be a squared plus b squared. And besides the shape and where everything is, in some ways you can confuse it, but Joe, in some ways there's not as much new stuff to memorize. In a way it's nice, but in a way it's tricky. But the shapes are very different. As you guys are drawing it, do you see the curves go out instead of in? In ellipses. I know they weren't two parabolas, I know. But the curves went in, the focuses were in, right? The vertices were out. For hyperbolas, it's just switched. The vertices are in, and the foci are follow the Pac-Man, right? The foci are follow the parabolic reflectors. The foci are, they have to be out. They have to be in the curve. So some things are very similar. The center will still be HK. That's nice. But there's one thing this graph doesn't show you. Two things, technically, that are pretty important for hyperbolas in determining the shape. Ellipses had A's and B's that held it together and showed us how wide or how flat it was. Hyperbolas, if you get your center, your vertices, and your foci, yeah, I know, wait, hold on. Joe just mentioned there is absolutely no B in this picture. If you just draw your center, your vertices, and your foci, how high do you go? How squished, how narrow, or how wide, how stretched are your branches? Where is the B? Kind of a tangent line, except actually, Joe, they're actually asymptotes. They're not going to connect. They go through the center, but the center is not a part of the graph. These are actually the asymptotes of a hyperbola. And here's where the B is, which is kind of weird and kind of out there. Here's your A. Your B joins with A to get you to the asymptote. And depending on how broad or how narrow your asymptotes are, will determine how broad or how narrow your hyperbola branches are. Could be. Which makes it different from ellipses. Ellipses, A was always the major dude. A was always the head dude. But in hyperbolas, A is always the positive. And that should be a note we should probably put out here. A always goes with the positive term. Positive term, oh yeah. In hyperbolas, one guy is technically positive where one guy is negative as far as the x's and the y's. A always goes with the positive term. So in section 10.3, we talked about A being major. A is the bigger denominator. But in this guy, A is the positive term. And whichever term is positive also determines which way the hyperbolas go. Wait, which way they go? I don't get it. They just go that way, don't they? Or that way. Where's A now? With the Y. So where are the hyperbolas? Up and down, vertically apart from each other, as opposed to right and left, horizontally apart from each other. But the whole bigger, smaller thing isn't what determines it anymore. You guys okay if I draw my asymptotes to this guy too for a bit? Let you guys catch up? Ooh, that was not very well drawn. I apologize. Oh well, it's close. So this way, if I go from the center to the asymptote, but if you notice on this one, B was how far up to get to the asymptote, A was how far over, B was with the Y, A was with the X. This one, B is how far over, A is how far down, B is with the X, A is with the Y. There's quite a bit of excitement going on. Not sure why. The enthusiasm. Awesome. Seriously, really cool. They're fighting over an answer on a review problem. And I was like, the enthusiasm is awesome. I'm like, no, actually, it's cool. And I came back. Geometry, probably? Or algebra? Miss Sutherland teaches both. But they're like up at the board, and they're like, ah, and they're teams. Anyway. So then, guys, guess what? Down here, the center is HK. Something was 4, something wasn't 4. I have no idea. Vertices. Hey, guys, if the orientation switches, what do you think I'm adding and subtracting A from instead of the H? So how about with the foci? Who am I adding and subtracting C from instead of the H? Got him, coach. This is your yellow box for, well, this on top of what Joe and I were talking about a second ago as far as C squared now equals A squared plus B squared. Like an ellipse, but we have to push the foci out instead of bringing the foci in. C is greater than A. And then you guys see the asymptotes at the bottom. There we go. But long story short, what were we able to get? The yellow box. How important is the yellow box to these sections? So important. So what are we going to do tomorrow? What do you think? Examples. Right? Examples. If you guys want to take a picture of it on the way out the door, it's going to be really helpful to have this yellow box ready to go. Are we tracking? Later, Gators. Later, Gators. Oh. Oh. No, it's okay. No, it's okay. I totally don't need to be in the picture. I was being facetious. Bye, guys.